Welcome to homework.
Hey, it's Clarissa right here. So we're going to use the parametric equations, which is x is equal to a cosine of theta, and y is equal to b sine of theta, and theta is between 0 and pi. We get ds to be equal to the square root of dx over d theta square plus dy over d theta square, which is equal to the square root of negative a sine theta square plus b cosine theta square, which is equal to the square root of a square sine square plus b square cosine square. We're going to plug this into our s equation. So 2 pi from 0 to pi, b sine theta, and we're going to place this right here. This is equal to 2 pi b from 0 to pi sine of theta square root of a square minus a square cosine square plus b square cosine square d theta. This becomes equal to 2 pi b from 0 to pi sine of theta square root of a square plus b square minus a square cosine square d theta. We get a u value of cosine, so du has to be equal to negative sine d theta. So s is equal to negative 2 pi b from 1 to negative 1 square root of a square plus b square minus a square u square du, which is equal to 4 pi b from 0 to 1 square root of a square plus b square minus a square u square du. We know that a square minus b square is equal to a square times e square. So this is equal to 4 pi b from 0 to 1 square root of a square minus a square e square u square du, which is equal to 4 pi abe from 0 to 1 square root of 1 divided by e square minus u square du. Using the table of integrals, we get 4 pi abe u over 2 square root of 1 divided by e squared minus u squared plus 1 divided by e squared over 2 inverse sine of u over 1 divided by e from 0 to 1, which is equal to 4 pi ABE square root of 1 minus e squared over 2e plus 1 over 2e squared inverse sine of e. This becomes equal to 2 pi AB b over a plus 1 over e inverse sine of e. For part B, we're doing a similar approach, but we're going to use the minor axis. So we get theta to be between negative pi halves and positive pi halves. But we use the same parametric equations, which is x is equal to a cosine and y is equal to b sine. So we get the square root of a squared sine squared plus b squared cosine squared. But for s, we're going to use 2 pi integral from negative pi halves to positive pi halves a cosine theta square root of a square sine square plus b square cosine square d theta, which becomes equal to 2 pi, the integral from negative pi halves to positive pi halves a cosine theta square root of a square minus b square sine square plus b squared d theta. We're using u to be equal to sine of theta. So du is equal to cosine theta d theta. So s becomes equal to 2 pi a from negative 1 to 1 square root of a square minus b square u square plus b square du, which becomes equal to 4 pi a square root of a square minus b square from 0 to 1 square root of u square plus b square over a square minus b square du. We know that the square root of a square minus b square is equal to ae. So this becomes equal to 4 pi a square e from 0 to 1 square root of u square plus b divided by ae square du. We're using the table of integrals, and we get this to be equal to 4 pi a squared e times u over 2 square root of b divided by 8e squared plus u squared plus b divided by 8e squared over 2 ln of u plus square root of u squared plus b divided by 8e squared from 0 to 1. I'll erase some of here to make more room. Continuing on, this becomes equal to 4 pi a squared e times 1/2 square root of b divided by 8e squared plus 1 plus so plus 1 plus b divided by 8e squared over 2 ln of 1 plus square root of 1 plus b divided by 8e squared minus 4 pi a squared e times b divided by 8e squared over 2 ln of b divided by 8e. And this becomes equal to 2 pi times a squared plus b squared over e ln of e plus 1 over b divided by a. And this becomes equal to 2 pi times a squared plus b squared over e ln of 1 plus e over the square root of 1 minus e squared.